Okay, today we're talking about Chapter 1, Section 7, Linear Inequalities in One Variable. Okay, and as usual, these chapters are adequately named. We're going to be talking about linear inequalities. So when we talk about inequalities, we're going to be talking about equations with greater than, less than, greater than or equal to, and less than or equal to. Right? And then in one variable makes sense. In one variable makes sense because we're just going to be using one variable. We're not going to be having two variables. Okay. This could be a good start. Alrighty, so this reads from the top. Unlike equations that usually have a finite number of solutions, all right, so what that means is what we've seen in the previous sections, whenever we'd end up with a solution that was like, x is equal to 7, okay? So unlike that, inequalities often have infinitely many solutions, okay? So the reason why we say infinitely many solutions is because instead of saying x is equal to 7, we might say something along the lines of x is less than 7, okay? And we're going to say it has infinitely many solutions because, well, try to list every number that's less than 7. Okay, and of course, you might go to 0, but then you'll recall really quickly, oh, -1, -2, -3, -4, all the way to negative infinity. All right, so that's why we say that it has infinitely many solutions. And honestly, I probably jumped ahead of what's being written about here. For instance, the inequality 2x minus 3 is less than or equal to 5 has infinitely many solutions because there are infinite values of x for which the inequality is true. Take, for example, the numbers -1, 7/2, and 4. If we substitute each one of those into this equation, it makes a true statement. Okay, and of course that makes sense because if we were to actually solve this, be 8, it would be x would have to be less than or equal to 4. So every single number less than or equal to 4 would make that true. And of course all three of these are indeed less than or equal to 4. Of course 4 is equal to 4. All right, so let me actually try to read this one instead of going off on my own. Because I do feel like I double dip, don't I? All right, so in fact, any real number x that is less than or equal to 4, yeah, see, makes the inequality a true statement. We certainly cannot list all solutions to this inequality individually. Thus, there are typically three methods used to describe the solution to an inequality. Method number 1 is to graph the solution on a number line. Method number 2 is to write the solution in set builder notation. We'll talk about that in a moment. And method number 3, write the solution in interval notation. So figure 2 shows the solution to the inequality, and here's figure 2, to the inequality in these three ways. In this section, you will learn how to solve such inequalities. You may want to review the terms set builder notation and interval notation, which are described in section R1, review 1, okay? So I will obviously go over them, but if you need to, guys, literally spend like 2 minutes in section R1 and get a very, very thorough understanding. But obviously, the way we graph it, that's pretty simple, right? We graph it. We're going to be doing a lot of that. But if we say it is less than or equal to 4, what we do is we go out here to 4, okay, and then we put we can start with an open circle, okay, but then we'll say is it or equal to? The answer will be yes. So the or equal to means that we will fill in that circle, okay, so we will fill in the circle, and it's all the values that are less than or equal to 4. Okay, so that's how we would graph it. Of course, we're going to do plenty of examples of that, so don't worry if I'm kind of cutting through this really quickly. In set builder notation, this is the way to write in set builder notation. It looks a little weird, looks a little off, but it is my favorite way to write solutions because it's pretty no nonsense, right? The way you write this, they pretty much all start out the same. Okay, if you're talking about the variable x, you would say you put a little curly brace here. So, it depends on what variable you're talking about. If we have a y, an x, a z, an a, all right, in this particular case we would say x, okay, and then you would make just a straight vertical line. What that vertical line means is such that. So x such that x in what should x be, okay, and in this particular case x should be less than or equal to 4, okay. And again, set builder notation is just basically a no-nonsense way of writing it. You're just basically writing the statement here, right? There's no thinking. It's just you write the statement. And we'll talk about that again more as we go. And then of course interval notation, right? This would be interval notation, right? And if you forgot review one, or if you didn't go and look at it, all right, you notice that we have a parentheses one way and a bracket the other. Right? The parentheses and brackets mean something. The parentheses means that we don't include it. Okay, so if this were negative infinity to positive 4, that would mean that we are getting infinitely close to 4, but not actually being 4. That means we're going from negative infinity to 3.9999999999999. We'll never, ever, ever, ever touch 4. Okay, but the bracket means that we do include it, so that would mean that yes, we go to 4, so negative infinity to 4, right? Now, infinities will always have parentheses because infinities aren't numbers, they're concepts. Okay, so infinities will always have parentheses, whereas parentheses on a number means that we don't include it. Okay. So the inequality 2x minus 3 is less than or equal to 5 is called a linear inequality. Again, linear meaning that it's that we are using that it's a variable raised to the first power. All right. In this section, you learn techniques necessary to solve linear inequalities in one variable. So our definition here: a linear inequality in one variable is an inequality that can be written in the form ax plus b is less than c. Now, real quickly, if you recall, previously in this chapter we would have a linear equation. Okay, and the equation, okay, again, equal in linear equation was when we had an equal sign there. Ax plus b is equal to c. Okay, but now we're going to talk about linear inequalities. So instead of having an equal sign, we're going to be having an inequality symbol, one of these. Well, actually, sorry, one of these. Okay, so kind of the same concept we touched on before, except now we're talking about inequalities. Okay. See, can I? Yeah, we can put it right here. Okay. So, properties of inequalities. Whenever we begin to perform the algebra on these inequalities, you're going to recall some of these rules, hopefully. Okay. So, if you are, this isn't what I'm looking for really. Yeah, it is. Okay. So these first three rules are basically what you expect, right? What you do to one side, you do to the other. All right. So if you add, we'll go over here. If you add 4 to one side, you must add 4 to the other. If you subtract 6 from one side, you must subtract 6 from the other. If you multiply by 5 on one side, you must multiply by 5 on the other. All right. Those three are easy peasy. Nothing needs to be done. Okay. However, and this should be something that you should recall here. If you are multiplying both sides, and let's see, right here, if you're multiplying both sides of an inequality by a negative sign, remember you have to change, you have to flip the inequality. Okay, so here notice how if we're, well, I accidentally need a circle. So if we are multiplying both sides by -5, since we're multiplying by a negative number, we are changing from a greater than to a less than. Okay, everything else being equal, but that's all we have to do. Okay, so let's go ahead and put this in. Maybe they should have their own pages, actually. So let's kind of like things to look nice and neat. Which one of these? Oh, this one. All right, close enough. All right, so these are our properties. I stopped talking on this one, but it same procedure that you've seen before, right? If we divide by a negative number down here, then we also flip the inequality. Okay, but if we divide by a positive number, it's just what you do to one side, you do to the other. So realistically, the only big differences, or not, I wouldn't say differences. The only big changes of what you do to one side, you do to the other, are if you add, subtract, multiply, or divide by both sides. However, if you are multiplying or dividing by a negative number, and I put stars by them, number 4 and number 6, then that is when you flip the inequality. All right, so enough nonsense. Let's get to the fun part. I'm sure many of you like to learn by doing, so here, let's do. Okay. Alrighty, so solve the inequality, express the answer in set builder notation. All right, cool. So here we go. Solving the inequality. What we're going to have to do is we're going to have to get rid of the parentheses and just we got to shave everything off, and we have to get to an x is less than something. Okay, so let's get to work. All right, so here we go. So we've got 2, and there's going to be minus 5x plus 10 is less than 12 minus 8x plus 7. Okay, so again, all I did, all I'm doing so far is I'm just distributing. I distributed the negative 5 through, and I distributed the 4 through. Okay. All right, so let's do some let's combine like terms on both sides here. Okay, so the left side becomes a negative 5x plus 12 is less than, and on the right side it looks like we're going to have a negative 8x, and then what, plus 19? Right? Yeah, plus 19. All right, and then let's go ahead and add 8x to both sides. So we're going to add 8x over here, and they cancel. We're going to add 8x over here. Okay, oops, add 8x. So we're going to have a 3x over on the left side, right? And then let's go ahead and subtract 12 from both sides. So that cancels that. We subtract 12 over here. We have a positive 7. Okay, and of course we have that inequality sign there. Alrighty, and then we have a 3x is less than 7. We're going to divide both sides by 3. So we're going to have an x is less than 7/3. Okay, and that would be our solution. And if we express the answer in set builder notation, okay, set builder notation, again I said curly bracket and then my variable and then a vertical line every time. Okay, well, and again, if you phonetically, you would read that as x such that. Okay, again, that vertical line, such that. What should x be? Okay, well, I said I like set builder because it's just basically you just rewrite what was said, right? Well, x should just be x is less than 7/3. That's it. That's all x should be. X should be less than 7/3. Right, and that's set builder notation. And I'm pretty sure, if I recall, this section has a couple problems where it's like, write it in, do it graphically, set builder and interval notation. This one just wants it in a number line and interval notation, but we're going to go ahead and put in set builder just because, again, it's easy, so we'll touch on it. Okay, so let's go ahead and solve this inequality. All right, so we're just gonna do a little bit of mental math in our head. So let's go ahead and let's go ahead and subtract. Yeah, we'll do. Okay, so let's go ahead and add 4x to both sides. Okay, and then we're gonna add 3 to both sides. So what I'm trying to do is I'm gonna get rid of the 4x on this side, and I'm gonna get rid of the 3 on this side. Okay, so if I add 4x to both sides, I'll have a negative 5x on the left, and if I add 3 to both sides, I'll have is greater than or equal to 10. Okay, so again, just did some mental math. Just that's it. Okay, and then what I'm going to do here is now I'm going to divide both sides by a negative 5. So by dividing by a negative number, I'm going to flip that inequality. So it's going to become an x is less than or equal to negative 2. Okay. And that's it. So now let's do this, graph this solution on a number line. So on a number line, what number should, or what color? Let's go and make it yellow. Okay, so if you have a number line here, okay, and let's go ahead and let's put a 0 here. No, not right there. A 0 here, -2 here. Okay, infinity going this way, and negative infinity going this way. Okay, so if we were to graph this on a number line, we're saying x is less than or equal to -2. Okay, so let's go out here to a -2, excuse me, and we're going to put a closed circle at -2. Okay, it's closed because we have an or equal to symbol. If it were strictly just a less than, then we would make an open circle. Okay, but it is closed, so we're going to, I'm sorry, it is a less or equal to, so we're going to make it a closed. Okay, and we're saying that x is going to be less than or equal to -2. So less than or equal to -2 are all the numbers down this way to -infinity. Okay, so that is graphing it on a number line. Now if we express this answer in interval notation, okay, so interval notation is basically looking at the number line and stating on what interval we are located. Okay, well, it looks like this green line here is going, you know, from it, like it occupies the space from -infinity all the way to -2, and that's it. That's the solution. If it's occupying that space on the number line from -infinity to -2, then that must be my solution in interval notation. Okay, so -infinity, comma, -2. Okay, now we're going to put in our parentheses and bracket. I said earlier that infinities, whether positive or negative, always have a parentheses. Now that -2, it's either going to have a parentheses or a bracket. And you'll know because you're going to, again, look at this sign. If it is an or equal to sign, we're going to make a bracket. Okay. If it were just simply a less than 2, then we would have made a parentheses. Okay, but since it is an or equal to, we do make a bracket. And then I said we're going to do, excuse me, I said we're also going to do it in set builder because it's easy, and I feel like it's just one of those things that, you know, you're not used to, so seeing it multiple times really helps. Okay, so I said the same thing we're going to do, or yeah, we're going to do the same thing with all of them. Curly brace, what variable are we using? We're using x, and then such that. Okay, well, what should x be? Well, that's easy. We just have to rewrite that. X is less than or equal to -2. Okay, so that's it. So you notice how I like interval notation so much better. I mean, graphing, I got to do all this. Interval notation isn't terrible, right? But set builder, you just rewrite the answer. That's really it. You just rewrite the answer, except you're gonna be putting this in front of it, right? Ugh, fractions. Everybody hates fractions. Why do they do this to us? It's a cold, dreary day outside, and we're doing fractions. All right, so we're probably just going to do A on this page and then B on the next page. So let's go ahead and rewrite A so I can show how we multiply everything by the least common denominator. No mental math here. Okay. All right, so what we're going to do is we're going to look at the denominators, and let's actually rewrite the right side there to make it look a tad better. I don't know if that looks the same or not. Oh well. So what we're going to do, excuse me, is we're going to find the least common denominator. So what we're going to do is we're going to look at the 5, and we're going to look at the 2, and we're going to look at, there's an implied 1 there, so we don't have to mess with that, do we? Okay. So between the 5 and the 2, what is the smallest number that both will go into? Well, that's easy. It's 10, right? So what we're going to do is we're going to multiply this entire problem by 10. Okay. So we're going to multiply the first term, the first term by 10. Okay. So if I multiply by 10, what it's going to look like? It's going to look like this. It's going to look like 10, and then 1 minus 4w over 5. Okay. And then we know that the 10 and the 5, you know, they kind of cancel there. So we're going to have 2 times 1 minus 4w, okay, because we end up with 2 times that. Okay, so that's the thought or that's the procedure and how we go about doing this. Instead of writing out every time, I'm just going to go ahead and write, 2 times 1 minus 4w, but I wanted to show you that. So we're going to have a 2 times a 1 minus 4w. Okay, and then we're going to multiply this 10 over here. And once again, the 10 and the 2, they're going to cancel. So it's going to turn into a 5 minus 5w in the numerator. So minus 5w. And then we're going to be less than or equal to. And then finally, some nice easy math. We're going to have a negative 50. Okay, let's go ahead and get rid of the parentheses there. So we're going to have a 2 minus 8w minus 5w is less than or equal to negative 50. Excuse me. Hang on. Alrighty, so what was that? Oh yeah. Let's go ahead and combine like terms on the left and then move the 2 over to the right side, okay? So if we combine the negative 8w and negative 5w, we're going to end up with a negative 13w. We're going to subtract 2 from both sides. We're going to have a minus 52. Okay, and let's continue this up here. And it looks like, all right, it just wants us to solve this. So, I mean, there's no sort of graphing or anything like that, so we can just honestly end here, right? So if we divide both sides by a negative number, negative 13, we're going to end up with a w, and it's going to be a greater than or equal to 4. Okay, so w is greater than or equal to 4. Right, again, since we divided by a negative 13, a negative number, we flipped this sign. 13, 26, yeah, 4. And let's do B. Let's actually, oh yeah, I did do A. Let's put the A there, like that. Okay, so B. This is ridiculous. Okay, so B, let's see. We could go about this a couple of ways. And I'm going to be honest with you, I'm probably not going to do it the way the book would do it. All right, so it's similar to what we did before. If you recall, we looked at the decimal places. And we would say, okay, so we have a tenth, we have a tenth, and we have a 100th. So what the book's probably going to do is multiply this entire thing by 100. Okay, you can do that if you want to, and of course the book will have, I don't know, let's see. Okay, so maybe not. Well, let's see. Okay, yeah, the book actually does solve it by doing that. So if you want to do it that way, the book will also do it that way as well, but we're going to do it differently. Okay, so what we're going to do is we're going to we're just going to straight up do the math here. Okay, what I mean by that is we're going to go ahead and subtract both sides. Let's put that in red. We're going to subtract 3.45y from both sides. Okay, and I mean 3.7 minus 3.45 is 0.25. Okay, so that's what we're going to do. We're just going to do it that way. So we're going to have a 0.25y on the left. And then we're going to add 6 to both sides here. So we're going to have a plus 6 over here. So we're going to have 12.1 on the right. Okay, so it's going to be greater than 12.1. Okay, so I'm going to have to use a calculator here. It's 4, 20, it's 48. I mean, it's still going to be the same thing. 12.1. I mean, obviously it's going to be the same thing. But anyway, it's 48.4. Okay. So if we solve this, this will end up being y is equal to, or I'm sorry, not equal to. Sorry, y is greater than 48.4. And that's it. That was a little too easy, I guess. I don't know. Seems easy. Anyways, that's how we do that. Okay. And again, if you want to go ahead and do the multiplying by 100, the book has that example for you as well. But there are more than one ways to do this. Okay. So maybe I should. Alrighty. Man, I don't know what's wrong. I'm still a little flimmy rather. All right, so the weight of a laptop computer depends on several factors, including the size of the monitor, the thickness, the type of battery, and the type of internal hard drive. The weight of a typical 14-inch laptop varies between 1.2 pounds to 8.4 pounds. The weight can be expressed using the following three-part inequality. Okay, so looking here, we said that the weight can vary between 1.2 and 8.4. And holy smokes, do I not want to carry around an 8.4 pound laptop. But anyways, if it varies between 1.2 and 8.4, then we can put the weight between 1.2 and 8.4. And boom, we just made the inequality. Okay, and that's really it. Right, so a three-part inequality, the way you would, all right, it wants us to do this. Yeah, so it wants us to do all of them. Ain't nothing wrong with that. Okay, so in order to solve a three-part inequality, you're going to solve it basically like you would a two-part inequality, right? The way we've been doing it, with this numbers on one side, and equal to, greater than, less than, whatever in the middle, and then something on the other side. The way we solve those, what we did to one side, we did to the other. With the three-part inequality, what we do to one side, we do to the other two sides, right? So what do I mean by that? Okay, so let's go ahead and rewrite all this. Again, this is a mental math problem that we could do, but I really want to demonstrate what we're doing here. Okay, so first thing we need to do is we need to clear the fraction. Okay, so we have the fraction here of a 3, so what we must do is multiply 3 by every single part here. Okay, and that's a little messy, but I'm going to erase it. So in order to clear that fraction of 3, we must multiply the entire problem by 3. And I guess I could have done that. No, that honestly looks a lot better, doesn't it? Multiply the entire problem by 3. And of course, we distribute. Okay. So if we let's keep that actually. So if we multiply the entire problem by 3, we end up with a negative 6 is less than or equal to, and then the 3's cancel, so we have a 2 minus 4x, and then is less than 15. Okay, and so we're out of room, so let's go ahead and snip this and put it on the next page. Okay, so that's where we're at. All right, next thing we need to do, and of course, same as always, we need to isolate the x variable. So let's go ahead and subtract 2. So we're going to subtract 2 from all three sides. Okay, and let's go ahead and keep that there. So let me fix this 2 over here. Minus 2. Minus 2. Okay, so we subtract 2 from all three sides. We end up with a negative 8 is less than or equal to, the 2's will cancel, so we have a negative 4x in the middle, and then we have a less than 13. Okay, and then the last thing we need to do here is we need to get rid of the 4 in front of the x. So what we're going to do is we're going to divide, and it looks like we're going to divide this by a negative 4. Okay, so the same rule applies here. If we're dividing by a negative number, we're going to be flipping the signs. Okay, so we're going to divide by a negative number everywhere. So it's going to be a negative 4, divide by negative 4, divide by negative 4, and divide by negative 4. In doing so, we're going to end up with, so a negative 8 divided by negative 4 gives me a positive 2. We're going to flip the inequality, and then we're going to have a negative 4 divided by negative 4 is going to be a positive x. And then we're going to flip this inequality again because we're dividing by negative 4. So we're going to end up having a negative 13 over 4. Okay. Now, the way that we write inequalities is we write them, in terms of less thans. Okay, because whenever we write these on a number line, that's how number lines work, right? If we look at a number line, the negative infinity is on the left, and we go to positive infinity on the right. Okay, so that's how we're going to write this. We're going to rewrite this inequality with less than symbols. Okay, so all you're going to do basically is just flip the entire problem. So you're going to say negative 13 over 4 is less than x, which is less than or equal to 2. Okay, and let's actually put that in green, just to kind of drive home the fact that that is, I wouldn't say it's we have to remember we have to put the solutions in all three of those ways. So it's not necessarily the final answer. But anyways, those two are indeed the exact same thing, right? If I were to say, if I were to use, greater than, if I were to say 27 is greater than 13, that's the same thing as saying 13 is less than 27, right? So that's all I did going from there to there. Right. So let's go ahead and put our solution on a number line. So let's put us a nice little there. All right, so on a number line, we have our number line here. We've got infinity on this side and negative infinity on this side. All right, so if I were to write this, so we need a 0, 2, so we're going to have a 2 over here. Looks like a negative 13 over 4 here. And we'll put the 0 here. Okay, if I were to write this on a number line, what this solution is saying is that x is going to be between negative 13 over 4, and that's an actual horrible 13. There we go. All right. So x is going to be between negative 13 over 4 and a positive 2. Okay. So what we're going to do is we're going to draw on the number line just a solid line between negative 13 over 4 and positive 2. Okay. We're not done yet with we're not just going to do that though, because we have to pay attention to the inequality symbol. Okay, so this will start us off. Okay, all right. Well, at negative 13 over 4, what should it be? Should it be a closed circle or an open circle? Looking there, looks like it needs to be an open circle, right? Because it is not an or equal to, so we're going to put an open circle. And then over here at 2, it is a less than or equal to, so we're going to put a closed circle here at 2. And let's make this nice and big, I guess. Right? And that's it. That's how we do draw it on a number line. Okay, next we're going to put it in interval notation. So interval notation, all you really have to do is, again, just simply look at the graph, right? So interval notation would just simply be, okay, so the interval looks like, oh yeah, let's not put parentheses and brackets just yet. Would be from negative 13 over 4, comma, to 2. Okay, well again, are we including negative 13 over 4? We have an open circle, so the answer is no. So we're going to put a bracket. At 2, we are indeed including it, so we can put a, wait, did I say bracket? I'm in parentheses there. We put a parentheses, and then on the 2, we do indeed put a bracket. Okay, and of course, you can do this without actually drawing a number line by just simply looking at the solution down here. Okay, because you would just simply say or look at these two numbers. Well, let's say here. I'm going to say that. You simply look at those two numbers, and then we have the or equal to sign, so we put a parentheses there, and we have a, oh gosh. Let me restart. You don't have to actually draw a number line, okay? Now, obviously, when you're requested to, you need to, but you don't have to get to this, because I did say earlier, you just look at the number line. If you were to look at your solution down here, you would see that x is between negative 13 over 4 and a positive 2. So we know my solution is between negative 13 over 4 and 2. So all you have to do is basically just look at the inequality there, okay? And since we have an just simply a less than, we'd put a parentheses there. And since we have a less than or equal to, we put a bracket there, okay? And then of course, you wouldn't want to keep all that in there. You would erase everything but those two numbers. But again, sometimes I say too much. Lastly, my favorite, set builder. Again, same thing every time. My variable being used as an x, such that, well, what should x be? Well, just got to rewrite this, right? So it should be negative 13 over 4 is less than x, which is less than or equal to a positive 2, and another curly brace. See, well, that's my favorite. you just rewrite it, right? All right, so oh, this is actually, yeah, we can't just skip over this. Not skip over it, but sometimes I feel like I can say things better than the textbook, and I'm wrong about 90% of the time. So here we go. Starting from the top here. All right, so before we solve compound inequalities, it might be a good idea to review the concepts of intersection and union. Okay, so you can obviously go to review 1 and review those concepts, and I really think you should. All right, um, but for now we're not gonna be bouncing back and forth in this lecture. So a compound inequality consists of two inequalities that are joined together using the words and or. Two compound inequalities are shown below. A, you would read x plus 2 is less than 5 and 3x is greater than or equal to negative 6. Okay, and then the next one you would have is x plus 3 is less than or equal to 1, or 2x minus 5 is is greater than 7. Okay, now real quickly, and I know some of your minds drift along during these lectures, and a lot of times people do come back to golly, when am I going to use this? Well, one of the coolest classes I ever took was in grad school, and it was called Linear Programming. And basically, what you do is you just come up with you. I mean, you have an infinite amount of these inequalities that you want to, right? And when you solve for them, you end up with a oh shoot, what was it called? I don't know, you end up with a preferred inequality. So basically, if you're saying, I want these kind of shoes to be priced at this, I want these kind of shoes to be priced at that, and I want, these last pair of shoes to be priced at this, all right? Well, you can figure out the way to have the most profit selling shoes by setting up every one of those inequalities and then solving from there. It's really interesting. It's called linear programming if you're interested, and it's definitely something that you as a college first or second year college student would be able to understand. Okay, so it's nothing that's extraordinary and too much theory. So if you want to go ahead and check out something called linear programming, it's really cool, and we use that in here. But anyways, a number is a solution to a compound inequality involving and if that number is a solution to both inequalities. Okay, so in A above, the number 2 is a solution to both inequalities. Okay, thus 2 is a solution to the compound inequality. So if I were to plug in 2 into both of these, it would work. Okay, going down here to the next paragraph. A number is a solution to the compound inequality involving the word or if that number is a solution to either inequality. Okay, so the whole point of this is if we see the number and, we're looking for the solution to both of them. And it has to be both. It has to work in both. If we are looking for a solution with the word or, then it doesn't matter which one as long as it works, right? Whenever we think of and, we then determine the intersection of the individual solution sets. All right, and then down here we then determine the union. So whenever we think of intersection, we were going to think of and. Okay, so let's put and here. And put an arrow, and whenever we use the word or, we're going to use this union. Okay, so whenever we hear and, we think intersection. Whenever we think or, we think union, and that's it. All right, I say that's it, but obviously, so some more has to be done here for us to really drive this point home. So let's get to some examples. Well, we'll go ahead and put this in the notes. Alrighty, so solve the compound inequality with and. Okay, so in order to solve this with and, solve the compound inequality. 7x minus 2x minus 7 is less than negative 1, and 3x plus 5 is greater than or equal to 3. Write the solution in interval notation. Alrighty, so here's what we're going to have to do. We're going to solve both these for x. Okay, so let's go ahead and write this one over here to the left. 2x minus 7 is less than negative 1. And then we have over here 3x plus 5 is greater than or equal to 3. Alrighty, so let's go ahead and solve the left one here. So if we add 7 to both sides, we end up with a 2x is less than 6. And then if we divide both sides by 2, we end up with x is less than 3. Okay. And on the right side, if we subtract both sides by 5, we have 3x is greater than negative 2. And if we divide both sides by 3, we end up with x is greater than or equal to a negative 2/3. Okay, so these are my two solutions. Now, it wants us to write this solution in interval notation. And there may be some among you that can, and at some point in the very near future, you're going to be able to do this in your head anyways, right? So if we envision a number line, we said this is going from 3 down to negative infinity. This is going from negative 2/3 up to positive infinity. Then they overlap from negative 2/3 to 3. Okay, so that makes sense. But what we're going to do instead for right now is we're going to let's do it this way. What we're going to do now instead is we're going to graph them first. Okay, so x is less than 3, and what's over here? 2/3. All right, I'm changing the colors here because I want to color coordinate these on a number line, and I reserve green for my final solution. 2/3. Okay, so let's draw us a number line real quick. Okay, let's put a 0 here. Looks like, let's go and put a, That sucks. I don't like the fraction, but we'll live with it. Okay, let's put a 3 here, and we'll put a negative 2/3 here. Alrighty, so this is my number line. And if let's go ahead and draw let's go from left to right. So let's go ahead and draw the x is less than 3 on this number line. So it's less than 3, so it's going to be an open circle. And we're going all the way down to negative infinity, okay, because it is less than 3. So this is how I draw that solution. And then in blue, x is greater than or equal to 2/3. So here at negative 2/3, we're going to put a closed circle, and we're going to go all the way to infinity there. Okay. Now this being an and right here and right here, right? What we're going to do is we're going to look for the overlap, right? And where do they overlap at? Well, wherever we see the blue and the yellow, that's where they overlap. What it looks like we overlap at negative 2/3. And then we go all the way to 3. Okay. Well, now we have to figure out, do we do parentheses or brackets? Well, at negative 2/3, the yellow line is including it, right? Because it's running right over it. And negative 2/3, the blue is also including it, right? So at negative 2/3, we do include negative 2/3 there, so we're going to put a bracket. And then at 3, well, the blue line goes straight over the 3, so it's blue line's obviously including it. Well, but the yellow line, there is an open circle there. So that open circle means that we're not including it. So therefore, we're going to put a parentheses there. Right? And that is the solution there with and. Okay, so and is basically where we overlap. Okay, or, which we'll probably do on the next example, it doesn't matter who's who, it's just there, right? So that's example 5. Excuse me. Number 6. This is going to be an or, so it doesn't matter which one the solution is to, because we'll just write down the solution to all of them. So similar to before, we're going to go ahead and rewrite. We're going to put this on the left. So 1 minus 3x is greater than or equal to a positive 7. And then we have a 3x plus 4 is greater than a 7. So let's go ahead and solve these. Let's see what I do. We did yellow to blue. So yellow looks like we're going to subtract 1 from both sides on the left here. So if we subtract 1 from both sides on the left, we're going to have a negative 3x is greater than or equal to a negative 6. And then if we divide both sides by negative 3, we're going to have an x. And then we're going to flip that inequality. What did I do here? Oh, I'm sorry. Okay, so what we're going to do is we're going to flip that inequality because we're divided by a negative 3. So we're going to end up with a less than or equal to 2. Negative 2, sorry. Negative 2. And on the right side, what we're going to do is we're going to subtract 4 from both sides. So if we subtract 4 from both sides, we're going to end up with a 3x is greater than 3. And we divide both sides by 3, we're going to end up with x is greater than 1. Okay, so similar thing here. We don't necessarily have to draw a number line at this stage, but for those that want to be very thorough and fully understand, for those who want to be very thorough and fully understand what you are doing, I do encourage you to indeed draw the number line. And we're using zeros, so we're going to put a 0 here, put a 1 here, and a negative 2 here. Okay. So in the yellow, we're saying that x is less than or equal to negative 2. So it is a less than or equal to sign, so we're going to put a closed circle there. And we're going all the way to negative infinity. Now the blue side, it is a x is greater than 1. So we're going to put an open circle here at 1, and we're going all the way to infinity. Okay. All right, now remember this is an OR, so we're not looking for overlap. We're just looking for where does this graph have yellow and blue on it, and that's it. Okay. So where this graph has yellow and blue on it is right here and right here. Okay, so how do I write that in interval notation? Well, it's not abundantly difficult, but there might be a little bit of a learning curve, and here's a learning curve. So if we say x is less than or equal to negative 2, okay, what we would do is we would say, let's actually put this in yellow. We would say from negative infinity, right, all the way to negative 2, and we include it. Right? That's where we would write that in interval notation. All right, and then the blue one, how would we write that interval notation? Well, we're saying x is greater than 1. Okay, so we would say we'd go from 1, and we'd use a parentheses because we're not including 1 all the way to infinity. Oops. And we put a parentheses on infinity again. Okay. So basically what we did was we wrote them both in interval notation, but that's not the solution yet, okay? The solution, we just have one more step, and what we're going to do is we're going to put the u here for union, and that is the solution. Let's go back real quick and look at this page, okay? When we said and, that we talked about the intersection, where do they overlap? When we said or, we said the union. Okay, so really easy to remember. Union starts with a U, so we put the U in between. Okay, there will come a time where we put the upside down U for and, but that is not today. But when we talk about union, we put a U there. Okay, so what we did for this particular problem, we unioned, right? We brought them together. Both of my interval notations with just a u. So that's it. So basically what you're going to do for unions or the ors, right? So let's go ahead and put those or for the ors, is you're going to put the union between the two of them. Okay, you're going to write them both out in interval notation. So notice how this is just this, and this is just this, and then we're just put that nice fancy u in between. That's it. Okay, so that is the union. So the last example we have today is going to be a compound inequality with no solution. Okay, so this is going to be a compound inequality with no solution. So let's go ahead and do the same thing we have been doing. So let's go ahead and put, let's rewrite, oh, it's a little thick. So let's put 3x minus 1 is less than negative 7. And we're going to have a 4x plus 1 is greater than 9. Okay, so let's go ahead and solve both of these. So we add 1 to both sides. We're looking here on the left. So we add 1 to both sides. We have a negative 6. We divide both sides by 3. So we're going to have an x is less than negative 2. Okay, and on the right side, we subtract both negative. Oh, let's put. Sorry, got to do the color coordinating here. And on the right side, if we subtract 1 from both sides, we have a 4x is greater than 8. We divide by 4. We have x is greater than 2. Alrighty. So again, we're going to put a number line, and this will be the last section where I actually do number lines every single time, because I do encourage you to be able to visualize these. Okay. So if I were to draw the yellow line on, or the yellow inequality on the number line, we have x is less than negative 2, so we're going to have an open circle here at negative 2, and we're going all the way down to negative infinity. We have looks like we have an open circle at positive 2 for the blue, and we go all the way to positive infinity. Okay. Now again, recall this is an and. Okay. And what we're looking for is we're wanting them to overlap. Okay. Well, they're not overlapping. Okay. There is no intersection. They're not intersecting anywhere on the number line. Okay. So since this is an and problem and they're not intersecting anywhere on the number line, the solution is going to be this, the empty set. Okay. Just like that. Okay. So what we're going to do is whenever we write sets, we write these nice curly braces like this. Okay. And honestly, that's actually a good answer as well. And might be more precise, honestly. But we won't deal with that right now. But the solution right now would be either this or this. Okay. Now, I have had and even instructors here at Ball State, I've signed papers for athletes, saying how many days they've missed and stuff. And I see other instructors, what they do whenever, like if a particular athlete hasn't missed a day, they put this 0, right? Which, depending on the context, obviously, I know that they meant 0. But in mathematics, don't ever put that as a 0. So like if you're gonna write the number 20, oops, if you're gonna write the number 20, don't write it like this, right? Because in mathematics, this has an actual meaning. It means the empty set. It means the set of nothing. Right. But anyways, these are my two possible solutions for example 7. So last up we got solving for applications. Okay. And that concludes today's lecture.